Another method for numerical integration is the trapezoid rule. So as you can understand from the name, now instead of dividing the regions into rectangles, we are dividing the regions into trapezoids. So this is the area we are trying to find, and we are dividing these into trapezoids, as you can see. So now we need to sum the areas of these trapezoids. And you know that the area of a trapezoid is what? The sum of the base times height over 2, right? So that's why we can say that for Tn, f of xi plus ai minus 1 plus f of xi over 2. So for the first one, we need to sum of this f of xi minus 1 xi times the height delta xi over 2. This is gonna give us the area of any trapezoid, and once we sum these trapezoids, you can see that this is the general form of the trapezoid rule. B minus a over n is gonna come from the base, over 2 is coming from the definition, and this sum, as you can see, f of x0 comes once because we are using this base only once for this trapezoid area. But for this base is used for the first trapezoid area and the second one. That's why it's coming 2 times f of x1 plus all the interval bases are coming 2. The last one also coming as only once. So this is the general form of the trapezoid rule, and you can easily use that rule. And I just wanted for you to understand how these tools are coming, because these bases are used for each 2 trapezoid. That's why they are coming twice, and the first and the last one is coming once. Okay, and this is just one example. Now we are trying to approximate this integral 0 to pi sine x square sine square x dx, and here our f is sine square x, and a is 0, b is pi. These are the borders of the integral. And remember our formula, b minus a over 2n times these f's. So we need to find b minus a over n. This is pi over 6. So in each interval we are starting 0, pi over 6, 2 pi over 6, 3 pi over 6, 4 pi, 5 pi, and 6 pi over 6, which is pi. Okay. And now we are writing our trapezoid formula. This is delta x over 2, b minus a over n over 2. 2n is coming from there, and plus the sums of the f's. And here we just showed the values of f of x0, f0 is here, f pi over 6, f2 pi over 6, 3 pi over 6. You can see how we found that. What you need to do is just plug them inside this formula, and you will see that we find pi over 2 as a numerical approximation to this integral. And easily we can find the real value of this integral here. You know that sine square x is 1 over 2 times 1 minus cosine 2x. This is how we transform sine square x into this function. And the integral of 1 is x. The integral of cosine 2x is sine 2x over 2. And from 0 to pi, you are calculating the definite integral. You will find that pi over 2. As you can see, the numerical approximation is giving just as the real value. This is, of course, for this particular example, it's not always the case, but for this one, our numerical approximation is working very well. And here, this is also the MATLAB code for that. You can see here 0.5, 1 over 2, yi plus 1 over times delta x. Exactly this base plus the other base times the height over 2. This is what we are doing in this for loop, in this iteration. And you can check easily with the previous one. Let's check that in the previous example, 16 minus x squared. So since I already have x and y values, I can easily call my trap with that one. And please try yourself for sine square x function. Exactly 29.25. So it is given like this was the midpoint, and it is given better than the midpoint, as you can see. Okay, my trap. me see in here. Okay, we will start Simpson's rule a little bit later.